Hi, it is Group 1 from University of Zaragoza, and it is one video of Principles of Turbomachinery's collection in the subject Fluid Installations. Understanding principles of turbomachinery is the first step we must take to check machines' designs. With some basic assumptions, we can understand the operation of turbomachinery, so this video will be dedicated to explain by a simple way Euler's theorem of turbomachinery. First of all, imagine the blade of a turbomachinery. Have you done it? Excellent. There it is. Pointed with number 1 is the input of the blade, and pointed with number 2 is the output of the blade. Now we are going to draw the path that would follow a fluid particle whatever. As many forces in physics, we are able to split those two paths, where absolute velocities, in a tangential and a radial one. Currently, and with second Newton's law of motion help, we are able to calculate the generated torque using this simple equation. This equation is known as Euler's Turbomachinery equation, and is one of the most important equations in turbomachinery's world. But we know that the rotor of the turbomachine is rotating with a omega velocity, so that if we consider this detail in the previous equation, we will transform the torque into a power. The term omega plus r is called drift velocity. If the power term is positive, it is because we are talking about a compressor, in which fluid takes energy from the turbomachine. And if the power term is negative, it is because the fluid is giving energy to the rotor, so it is a turbine. The power of the turbomachine is related with hydraulic height through the next equation. In order to introduce velocity triangles concept, it is important to understand the relative velocity concept. Imagine you are one of the billion of fluid particles that are entering in a simple turbomachine. You, the particle, have a velocity, the absolute velocity v, but the rotor has ones too, u. Now it is easy to realize the relative velocity concept. Relative velocity is what you, the particle, feel regarding rotor's ones. Now that it is clear the relative velocity concept, we are able to introduce triangles of velocity. So there it is a simple example. The angle between the absolute velocity and velocity of rotor is called alpha, and the angle between rotor's velocity and relative velocity is beta. If in a pump the fluid enters without centrifuged per rotation, the angle alpha is 90 degrees. So it is easy to see that there wouldn't be a v1 theta component of velocity, and the hydraulic height would be simplified by the next way. In the case of a turbomachine without output rotation, the fluid will exit without rotation energy, like the most of turbines. So v2 theta is 0. The hydraulic height would be simplified by the next way. With this simple concept, you would have to be able to face on easy and medium level problems of turbomachinery. We wish you have enjoyed this video, and that it has been helpful to you to have more curiosity about turbomachinery world.